So we have our part finished as far as the brazing goes. I've been cleaning it up a little bit. Wanted to go ahead and show you this amount of it right here where we're done. So I've been using the needle scaler to get in there. The flux from brazing is usually pretty tough to get out, especially down into places like this. So that's where a needle scaler really comes in and helps. And it also, if you're trying to match the look of cast iron, a needle scaler is your friend there. You can go in there and just needle scale, you know, a lot, and it'll kind of start making the surface of your buildup or your weld match the casting there. So there's now this is the ear that we had to build up. I got to drill and tap a hole there. So I am going to go and finish. I just wanted to show you what it looked like after we finished brazing it right there, okay? So I'm going to go ahead and take the air grinder and just kind of shape this into a more uniform looking area here. And then we're going to go to the machine and set it up and start doing our machining. So I thought it turned out good. It's not, I mean, I certainly would have liked to make the beads, the buildup look more uniform than I did, but it is a good repair. It's just not a, it's not a great repair, I think. But I do think that this is going to be a nice, strong repair for the part, and it's actually going to work pretty good. I can see that I missed some of that flux right here. I need to clean some of this off. I'm not sure what, there's a rod that sticks down right here. I think this is all just clearance. Whenever this plate, I think the plate goes on like this right here. So I think that's really just clearance for that rod. So we'll probably just kind of clean this up and kind of dress it by hand using the air grinder. All right, we've got that little bit of grinding done. I mainly wanted to focus on this ear and get this shaped. So we used the air grinder and the carbide burr, just blended the radius, tried to make this nice and uniform, flattened out the bottom of it there as well. And the rest of it we're gonna leave alone. We're gonna leave the buildup there. None of this buildup inside here is gonna affect this bore where the shaft goes through. I've already checked that, that's got clearance. You can just look down the side of it like that, and none of these beads are actually in this machined area. That bead there, that buildup, we're gonna leave it alone. This will actually help the strength of it there, just leaving all that material. And I got it uniform enough where I think it looks good enough like it is. So we're just gonna leave that alone. And a lot of this is gonna be machined out right here once this is a machined surface down in there. So this will be milled once we get to that. We'll start by milling this side right here first. We'll get it set up. I'll probably use an adjustable angle plate, get this mounted up there so that I can indicate this and get both ends of it running 0 to 0. I think the center of this is going to be slightly high from the outer corner. So I want to make sure that I get it as flat as I can. And I'm not referencing this surface right here to do that. I want to use the machine surface there to make sure that it stays flat. All right. Wanted to show you my setup on how I'm going to get this machined, at least on this side anyway, using my adjustable angle plate. And we've already got it bolted in. I haven't got it indicated yet, but I've got 4 strap clamps on the bottom and then just lined up one of the bolt holes with a T-slot there. So we got a total of five studs holding it down. So what we're going to do is we're going to run through the X-axis here. We'll jump back and forth, and I want to get this thing bumped around so that it's completely parallel to the X-axis there. And then once we do that, I'm going to indicate it front to back, and that's why I want it on this adjustable angle plate so that I can make sure that this reference here, this surface, is completely straight. This side was on the indicator, it was 5 thousandths off of this side here. So we're using the, that's the Starrett number 196 back plunge indicator. And you can see that I'm still low on that side, so we're gonna go back to this side since it's easier just to bump it down. 6 under. Okay, so we're within 1 thousandths there. Looks like I went 1 thousandths too far on that one. -5, -6. I don't know if I can bring it up any. I've got all the clamps pretty tight. I didn't want it to move easily. All right, so let's just reset that back to a 0 right there. That is looking pretty darn good. 0, 0. So I intentionally left this end a little bit high so that we could kind of bump it down a little at a time. And I'm going to show you what we're looking like on the indicator. All right, you can see we're dropping in the back. So I'm going to go ahead and let's see if we can go back here and see how far off it is. So not too much. What, about 30? I think I was about 30 thousandths total. On the angle division here, it's less than 1/2 degree off of 0. So let's just call that 80. Come back out here to the end. See if we can very gently. Just going to go a little at a time, try not to go over that. Still a little high. Let me go another 10. Still dropping. Yeah, still quite a bit. So there's 20 thousandths. So you see what I'm doing there. We're going to run it back and forth, and I want to make sure that we're 0, 0 on the ends right there, with the hopes that this area is just a couple thousandths high. So when we do our milling, maybe we can feather in the high spots here and kind of blend it with the existing machine surface. It's looking pretty straight though, even though it's still at an angle. 10 thousandths. Much closer. 5 thousandths now. So I'm gonna keep working at it just like you saw right there. I've got a thing indicated where I want it. What I have discovered is that there's a little bit of twist to the entire casting there. So it's hard to keep all 4 corners on exact 0. What I'm seeing is about 3 thousandths twist in it. So what I've done is I've evened it out here in the center across 0, 0 to 0, 0 and 0 on this side. All right, and then I've already know that I got front to back nice and level, but once I leveled out this area here, then it's going to throw off one of these corners by a couple of thousandths. So I feel good that we have the center of it where we're going to be machining 0 across there, and I know that I've got it level and plane. It's just we've got a few thousandths twist in the casting is what we got to deal with there, but I think that's going to be okay. It's not going to hurt to shave a couple of thousandths off this face right there. It's still going to work just fine. So this is indicated, and we're going to move on to start machining the buildup off there. The tool of choice today is going to be this Tungaloy Tongue Tri. It is the 2 flute indexable end mill 3/4 shank. It takes those triangular type of inserts there with a lot of really good positive geometry. It does a really good job. The the test cuts that I've taken with it and the jobs I've used it on, it's performed really well. So perfect for applications like this right there. It should do good on cutting that bronze buildup off that part right there. I've established a 0 position for the knee right here, right on this edge, and I backed off, and we're going to start cutting that down there. So I know once I get up to 0, we should be about where we want to finish this out at. Go across here, let's take 50 thousandths, go back the other way. Got one little area there. Not quite clean it up. I'll have to come back and hit that corner. All right, so I'm gonna take it to the 0 position that I had, which is gonna be 10 thousandths. I'll go 1 thousandth shy, that's 9 thousandths. Let's see what it's doing here. Looks like I got a little bit of a hollow down on that side. We're just starting to come in and touch the casting right here on this, so we're good on this side. 1 thousandths away on that one right there. So after touching this corner off with our 0 point right there, it just trimmed this. It's just barely touching this side. I took another 2 thousandths and we're just gonna cut it, and wherever it finishes out right here with an extra 2 thousandths is where we're gonna leave it. There we go. Still just a little bit shallow, like it didn't touch right there and right there. I can see my V's in there where we V'd it out. All right, that looks good. We got our bottom side finished out here. It looks great. So we're starting to get into our home stretch of the repair. We'll get this guy removed from the angle plate, and then we're gonna go ahead and bolt it back down to our fixture plate that we had made originally. And we'll just use the vise for that and get it all centered up so that we can drill our 2 mounting holes there, and then we got our 1 hole through this guy that's drilled and tapped. I've got the fixture mounted back in the vise, and I centered up on our hole pattern again. So once we get through of our milling here, I'll be able to go directly to the two hole locations that we got to drill. So we're going to start with the milling first. I'm going to use this inserted end mill here. This is the Tungalloy Tongue Force Rec, and 3/4 diameter. So it should fit in here nicely. And you know, with the carbide, we've got a little bit of that flux in here that we got to cut out as well. So that should be able to come through here and pretty easily mill this out. And we'll use it on this top area here as well. All right, so There it is. We'll go ahead and get it mounted up and start our milling. First thing I've done is come in here just over the edge of the cast iron, and I've established an elevation setting here. So we've got our knee set to 0, and that should be even with the cast iron right there. So I'm just going to back it down 1 full revolution, so 100 thousandths. Knock off that high spot. Let's go up another 50. Go up another 40 thousandths right there. I had to extend the end mill down so that the spindle of the mill would clear this flange. So we have it set about where we need. Just going to touch off on some high spots here and then start milling this out. What I want to try to do is get a depth established here. All right, well, I believe we're right at the top of the surface of the cast. We could probably go a couple thousandths deeper now, so I'm going to set a 0 right there. That was a tricky one to get in there to the film because of the pocket and this flange back here just not having a lot of access. And I didn't realize until I was kind of done with some of those shots that my other phone wasn't focusing like it should have stayed focused, and it didn't. So I apologize about the video, but hopefully you can kind of see that we got the job done, and that my tongue force rec end mill here worked out perfectly to get down in here. We had clearance. I was able to drop this down and clear the spindle here on the side. So that was the perfect tool to get in there and cut that out. We had some the flux that was still down in there along this side right there, and that stuff is extremely hard and it'll tear up a high-speed tool in no time. And the carbide inserts did great, still cutting perfect. So that part of it is done there. So the only thing we got left now is to drill the 2 mounting holes, drill and counterbore, and then we have our tap tool out here on the end that we got to do. We'll get our 2 mounting holes drilled and counterbored first. And let me double check my measurements before I spot that in. I'm going to just come up here on the DRO. I'm looking at my drawing. 3 7/16 from this hole to this hole. I'm there. 3 1/8 center to center. So that should be 1 9/16 halfway, 1.562 over on y-axis. So I've double checked that now, so we should be good. Here we go. Just using my spotting drill first. And I'm going to use a 21/64 drill bit. That's clearance size for 5/16. Let me just make sure of that. All right, I should be into the steel now. Yep. I think that was steel that I had coming out of it. Yes, okay, here we go. All right, drill successful. And I don't have the right, this is a counter bore. This is what I wanted to use, but I don't have the right size. So I'm gonna end up using, I got this 1/2" carbide end mill that we're gonna use to do the counter bore there. I'm gonna go ahead and get the drilling done over here because I gotta remove the chuck for the end mill and I gotta raise the knee up. So let's just go ahead and drill the other side first. Going negative 1.562. Right there. Make sure my drill is going to clear here. Yep. All right, let's spot it. All right, now that we got that hole drilled there, we're gonna go ahead and offset over here and drill and tap our 1/4-20 hole. We'll just do the counter bores last. So that offset, I measured it before we cut all that off. It's 11/16 or 0.687. Right there, 0.687. Right in that spot right there. Okay, we're gonna move on to the last stop, which is the counter bore for the 2 drilled holes. All right, there's our setting to 0. Can't seem to keep that thing to focus today. I don't know what's going on. That'd be because it's shaking around. It's causing it to lose its orientation. I don't know. All right, that first counter bore looks nice right there. We're gonna go ahead and we're gonna move across to the other side and get that one done too. Zero. I'm going up 330 thousandths. That's the depth of the factory holes.
$100. $200. $300. $330.
There it is. With the exception of a chamfer on the counter bore there, this is finished. Just finishing out this last op and I will be done. I just want to touch it and break that sharp edge. Just like that. That looks good. All right, now we're done with the exception of unbolting it and getting it out of there. This part is finished. Well, I'm happy to say that this job is completed, and I believe that it was a very successful repair in what we did here. Real happy to see it completed, and I feel 100% confident that this is going to be a strong repair that's going to last a long time, as long as this thing doesn't get hit unnecessarily. I believe that this probably ended up breaking because the unit ended up getting hit by something, causing it to fracture, and over time it just continued to break and get worse and worse. I think if it's functioning and bolted together just like it should, there's no reason why that thing should break again. But I'm happy with the repair. I left a lot of Braze material on there for the build up to provide some extra strength there for the cast to hold on to, and there's no reason why this thing should not hold just the way I repaired it right there. This is the method that I prefer to use for cast iron. I've been sharing a lot of these pictures and videos across social media as I was doing this job, and I didn't get as many as I expected I was going to, but you always do get the people that come in that have to say, hey, why not? Why not? Why not use TIG braze? Why not use nickel rod? The reason why I like to use brass, it is an old school, tried and true method to join and bond cast iron. And I believe when done properly, it's going to give you the strongest bond that you can get versus using electricity to make an arc and fuse the material together. So I think that if you was to go in here and maybe use nickel rod, possibly TIG it with a nickel rod, you would be successful in welding this thing back together, but I wouldn't have any confidence that the piece that would be as strong as it is with the bronze, with the brazing rod there. And that's from experience. There's a lot of guys that got a lot more experience in this stuff than I do, but I have been around this industry now for 25 years, and I've had to do a lot of this stuff over the years. Not only the stuff that I've done, it's the jobs like this that I've seen other people do that I know that this is a true method to repair this, and I feel 100% confident that it is truly repaired. You know, the downfall is that it's very labor intensive and it takes a lot of time, and when you got to pay a shop to do something like this, it's going to be expensive, you know. So there's no way around it. It just takes a lot of time. That's why if you can do jobs like this yourself, more power to you. Save all that labor and do the jobs yourself in-house and get it done. But I was happy to help Jack out with this project here, and I think it's going to be a good repair for him. So I'm going to go ahead and start getting the box back up here in a minute. I was going to show you, this is where this bolt goes right here. They got some kind of spacer in there, so I'm not sure what the use of this bolt here is, but they did have it. It is actually counterboard right there to clear the head of that. So this goes on here like this, and what I got to do, actually, I'm going to have to raise it up because that rod sticks down below that. You see you got this area here, and that's where this rod goes down, that shaft. It's some kind of oiling system, I believe. So I think there's going to be something that comes up around this. Is probably why they got that relieved the way they do. And so that cap goes on there. You got these 3 bolts, these socket bolts here that go in these holes, and bolt that down just like that. This is the top of the unit right there. And then you've got 2, I took these dowel pins out. These are some alignment pins that go in a couple of these holes on the bottom side right there. So I'll knock those back in there as well. But that's going to be it. All right. Hopefully you enjoyed this repair. I enjoyed doing it, and I feel so much better now that it's finally done, and I know it's gonna be a good solid repair. All right. We'll see you guys on the next job.